chapter number 12, that is file input output. So we'll talk about how we are going to deal with the files now. Just displaying the data, we have seen how to display the data, how it is important to display the data, and we have used the printf and scanf. We have used the console input output. Now there are certain scenarios where you would like to work on the files or the data. You need to keep them for long, that is not in a volatile memory but in your non-volatile memory also. And why you want to put it in the non-volatile memory? Because you want to work on that data later on also. So for that you can keep the data in the file, and in the operating system, most of the operating system, they keep the data in the form of file. So we'll talk about the input output operations which can be performed in this chapter. Data organization. Before we can talk about the input output, first we need to understand how the data is organized in the disk. If suppose that this is your program or this is our program, we have C library functions, and these C library functions we opt for them because there are no direct input output functions in C. Rather we have library functions. We don't have any command, I must say. We have library functions, so we'll use the library function, and these library functions in turn use the capability of operating system in order to deal with the disk, right? I hope you got the idea. So the data is stored in the disk. It is in actually the binary form. So how this binary form is stored in the disk, it depends on the operating system. But for C programmer, for us, it doesn't matter. Why? Because we are using the library functions and we are using the capabilities of operating system to perform the input output. So it is the compiler vendor. It can be any compiler from any vendor. Now it is the responsibility of this compiler to correctly implement these library functions and also take the help of operating system. File operations. When we are dealing with file or file input output, we have certain operations that can be applied on files. These are creating a new file, opening an existing file, reading from a file, writing from a file, and seeking means moving to certain specific location in between the file, and also the final one, that is the closing of a file. We'll have a program how to read from a file and display its content on the screen. So first we'll list that program and then see how and what we do while dealing with a program or how we deal with a file. So we have a program called display contents of a file on the screen, and this is stdio.h. This is very important because what we are using here, they are defined in stdio.h. We have certain variable, character variable. This is fopen. This is fopen means file open. So we use this fopen. This is the name of the file we want to open, and this is the mode in which you want to open. Now when this is being done, it returns some pointer to fp. So this is fp is a pointer. What is happening here? We have an indefinite loop. We are getting a character from this fp. Fp is now a pointer which is actually pointing to the first character of this file. So now we are taking one by one all the characters. We are checking for the end of file. If this is a file, say this is end of file. If we reach end of file, we break. Otherwise, whatever we have got in ch, we print it. So this goes on for indefinite till end of file is reached, and after that we break, and then we close the file. So what all we are doing here is this: when we execute this program, we are able to display the content of pr1.c onto the screen. First of all, what is this? We'll discuss each and every aspect one by one. Opening a file. Whenever we want to open a file, we have to use certain function. We want to open a file for reading or writing. So before we can read and write, we have to open the file. For example, we have a file called pr1.c. This is just an imaginary name, and we want to open it in read mode. So we use this fopen. This R is actually a string. Please understand. Fopen, I'll show you. This is fopen. Now this is the file name in double quotes, and this is the mode in double quotes. So this is the name, this is a string, but here we use R or any other thing. I'll tell you what we use. For right now we are using R. So this is a string. It is not a character. That is why we have a double quotes here. We don't use it in single quotes, otherwise it will become a character. So fopen performs what? This fopen function, file open, it does certain activities when it opens the file in read mode. First, it will search for the file on the disk. Okay, we need to open a file. For that, we have to see whether this file is on the disk or not. Otherwise, this fopen will raise an error, or it will return null. Then it loads the file from the disk into the place in memory called buffer. So from the disk, it will take and keep it in the memory, that is the RAM. Now it fopen sets the pointer to the first character of the file. First character of the file, or you can say the buffer. Now why we need a buffer? Because the file can be very large also. So if we have a very large file, we cannot have, this is inefficient that we take all the file and bring it into the memory. So we take a chunk or say a buffer. So say this is 100 byte. So every time we take 20 byte and place it here. This is how it is done. So it becomes quite efficient. This is what is done. Means this is your disk. Say you have a program called pr1.c. You can just take all that in the memory, or you can take a buffer in the memory. And what fp is doing is, fp is actually pointing to the first character of this file. And when we want to write the information, so if you want to write, whole file cannot be transferred totally to disk, because the RAM or memory to disk communication is taking time, because they have different speeds. So better is to take the content of the buffer and place it there. Now this fopen, we have a file. We use file fp. Before we do fopen, we have file, and this file is called what? This file is nothing but it is a structure. This file is a structure, and this you will find in stdio.h. This is standard input output.h. So it becomes very necessary, if you use this line, you use a hash include stdio.h. So now we have a structure and we have a pointer to this structure. This pointer to the structure will be pointing to the content of the file. More precisely, it is pointing to the first character or first position of the first value or character or anything on that file. How to read from a file? Now we can read from the file. We have to use fopen, file open. This is the function we use, and we can take some buffer, means you can partly or wholly read the content of the file starting from the first character. Now this fp is pointing where? If this is a file, fp is pointing here. Now you start reading it. When you are reading it, means you are reading the character, say, or you can read also the whole line. You can read a buffer size. This all is possible. So to read the file content from memory, we have a function called fgetc, and we will use, this is in our program, this is a fp, which is actually fp returned by fopen. Inside fopen we have the file name in double quotes, comma, the mode in which we open, and when it returns to fp. Fp is the pointer. Now this pointer can be used inside fgetc, so that one by one the character can be read. Now when fgetc reads one character, it automatically advances to the next character till the time we want it to happen. And this fgetc, if we put it in a while loop, or you can say an infinite loop, while 1, that means it is going to read one by one till indefinite. That is why we have used, or we can use in between. Every time we can check the character to be end of file. End of file is nothing but it is 26 in ASCII. So it's a special character which signifies or indicate that we have reached the end of file and we are not going to read beyond that. And when we are reading it, as I just said, EOF we use, and this EOF end of file is having a ASCII character, or it is actually a macro whose number assigned is 26. So this end of file, I must say not 26, basically EOF is equivalent to the ASCII character 26, and it is defined, this macro is defined in stdio.io.h. And fgetc is file get nc. This means from file get a character. We can also use the getc with the same effect. We have already used this getc, right? So we use this fgetc with a while loop, and we read one by one character till the time we reach the end of file. But when we are opening a file, it is not always necessary, or you should say the condition may be that the file is not there. If you want to open a file in read mode, if it is not there, how you are going to open? Or you want to write, it is not there, or I'll show you what problems can arise. So fopen we use for opening a file, and in this fopen we are passing the name of the file, double quotes, and the mode in double quotes. Now when we try to open and assign it to fp, the fp should get the pointer to the first character of the file, but it may happen that the file is not there. The file doesn't exist. So what fopen will do? It will fail. How it will fail and how it will indicate that I am failing? It will pass null to the fp, right? There are certain scenarios file cannot be open, or if you want to write the file and you see that the disk is already full, or some writing, some boundation is there on the file. So fopen will, at that time also it will fail. So it will return a null. fopen will return a null, and null is nothing but this fopen has defined null equal to 0, so it is going to return the 0. So how to handle it? I'll show you one program that we are including stdi.h. we are having a file pointer. Now we are opening it, fopen, this is the name of the file, this is the mode. Now when this we want to open, this fp will get some pointer or some value. This fp, if it is null, this null, if it is null, that means we are not able to open the file. For that we have to just exit. This we have to do for every file which we are opening or closing, or not closing, opening in any mode. How to close the file? When we are done with the file, means we have done the operation, we have to close it. You know, for closing we have to do nothing, just we have to use this fclose with the fp, and fp is just the file pointer which is returned by, say, fopen. So this closing of the file is necessary because we want this. And one more thing, when we are closing it, there are certain things when we are using this, say, fputc, so the memory is being assigned, there is a buffer also. So when we close the file, what will happen is the character in the buffer would be written into the file on the disk. At the end of the file, we'll have a character with ASCII 26. This needs to be written, and the buffer would be eliminated from the memory. That is what is done when you use this fclose. So you see that if you want really to clear things, you have to fclose. This is your responsibility. Let us write a program for counting characters, tabs and spaces. So we have known the basic input output in the file. Now how to compute number of characters and spaces, tabs, new line? These all are nothing but these are simply what? Simply the because they are not seen on the whenever you type in Word or say WordPad, you will not see it. That is why they are called blank spaces. So characters, apart from this character or other from this character, all these are the blank spaces. So what we will do, we will do here, we will stdio.io.h will include, we'll make a file pointer, we'll have some variables like this. These integer variables are simply for counting, that is number of L++. This is for number of tabs, this is for number of the characters and backspaces of tabs, you can say. This L, T, B, C are for all these. It depends on you what name you choose. I'll show you how we are going to compute it, for what we have used this variable. So now the main concentration of ours is opening a file, fopen. So we are opening a file called pr1.c in read mode, and after that we are using an indefinite loop. We are getting a C from this fp, that is fp is now pointing to the first character of the file, and we are using fgetC, and every time we check for end of file. If end of file is there, we break, and we see that if character is equal to end of file, and every time we read a ch, we increase NOC, that is NOC is nothing but number of characters, so NOC++. But if we get a space, if we get a blank, we get NOB++, so NOB is for the spaces. If we get a /n, that is we have a new line, this is for new line, NOL++. If we get a tab, we increment NOT++. So depending upon what comes with fgetC, all those characters are being matched respectively with the character, with the new lines, etc. And these are being computed, and means these are being incremented and computed, and finally these are being printed. So this is just a test run of any file which you give, and this gives you the simple idea how we can use a file, open a file, and simply a program, a very good and explanatory program can be derived from it. A file copy program, that means we want to have a file which is exactly similar to this file, so all the contents from this file will be transferred here. So we want fgetC, we know that fgetC reads the character one by one. Similarly, the fputc also does what? It reads a character, it puts the character in the file. It reads the character from the file, it puts the character from the file. So we'll have a program in which character by character copying is being done. This is stdio.h we have included. We have fs and ft. We have two file pointer. This is the source, this is the target. Say this is the source, this is the target, and we have taken a character variable. Now we try to open the first file, that is pr1.c. say this is the name of the file in read mode, and we have to check whether it opens or not, otherwise will come out. Now we will try to open fopen pr2.c. this is our second file, this is our first file, this is our second file, and now this we have opened in read mode, we have opened this in write mode. The write mode we have to check again. If this ft fails, that means if it is null, then we come out. But if everything goes fine, this is opened in read mode, this is opened in write mode, and there is no problem, then we'll go inside a while infinite loop. From fs, that is the source, we take every time one character. If this is end of file, we break, otherwise we just put this character in the target file. So one by one, see, I'll show you here. One by one copy. This one is copied here. This one is copied here. Like this, all these are being copied. And once this copy is done, there are certain buffers which you have opened. You close it by F-close. So this F-close will close the file. So this is self-explanatory, I guess, how this F-put-C, F-get-C works. Writing to a file. Now F-put-C is similar to put-ch function because both they are outputting the character. But this put-ch put the character on the visual display unit. But the F-put-C write to the file. So which file? Which is, say, if you have fs as file pointer, fs as source, and ft as target. So this file signify means you want to put it or write it in some file, say target file. And this goes from one character to one character, copy, and while terminates it. And we can copy or file copy program. We can do it with text file. But in order to copy the file .exe and .com, because these files are not text file but these are binary mode. Okay, first of all we should talk about file opening mode. The file can be opened, it depends totally on your activity or application how you open the file. So we are dealing with disk IO. We can open the file in read mode. So read mode also has various flavors, and F open we can have various other options like R, as we have just seen. That R does what? It searches the file. If the file is opened successfully, fopen loads the file into the memory and now sets a pointer, which is actually the FP, we are generally using it, which point to the first character in it. And if the file cannot be opened, fopen is going to return you null, NULL in capitals. So this is reading from a file. Then we have W. W is for writing. So it searches file. If the file exists, please understand, if the file is existing, the contents are withdrawn, or you can say they are overwritten. If file doesn't exist, a new file will be created, and if unable to open file, it will return null. A is for appending. Means you already have a file, the content are written up till here, you want to add the things from here. That means if the file is opened successfully, fopen loads it to the memory and now sets the pointer to the end of the last character. So if the file is not there, a new file is created, and file is not opened, then it will return the null. Then we have R+. So this will search file. If it is opened successfully, fopen is going to load it in the memory and set the pointer again to the first character, and it returns null if the file is not we are not able to open the file. So what are the operations which are possible? Reading the existing content, writing the new content, and modifying the existing content of the file with the help of R+. Now W+. W+ does what? Because W is for writing. So if the file is existing, the content will be automatically overwritten, and if the file is not there, new file will be created. So it is going to return null if you are not able to open the file. So what are the operations which are possible? We can write the new content, read them back, and you can also modify the existing content of the file. Then A+. Again append plus. So this is this searches file, and if fopen successfully opens it, it loads the file in the memory and set up the pointer which points to the first character in it. If the file doesn't exist, a new file is created, and if we are not able to open, it will return the null. So what are the operations which are possible with A+? We can read the existing contents, append new contents to the end of the file, and we cannot modify existing contents. Now string or line input output in files. We have already talked about character by character feeding or character by character reading and writing. But in various situations, we would want some whole string to be taken, which in turn becomes more efficient. So reading and writing strings of character from and to the file is quite easy rather than doing it with individual characters. So we'll write a program which writes the strings to the file using the fputs, file put string, like this. So this is a program which is receiving the strings from the keyboard and it will write them to the file. So this is our stdio.h. We have a file pointer, we have a character array. Now this is our imaginary file, and this we have opened in write mode. Now if this is not we are not able to open it, we'll say okay, there is a problem, we come out. Otherwise, if everything goes fine, we'll say enter a few lines of text. So whenever a user is entering the line, we use while strlen means string length of this getS, means first we will take the getS, means getS function will use this string, this s we will use, we'll find out the string length when it is greater than 0. That means we want something to be written by or given by the keyboard, we don't want it to be 0. So if it is there, we will put the string into the file, and we have to specifically, after that, we have to put a /n after that for FP, and then we close the FP. So this is the sample run of this program. So what is happening here is, Each string is terminated by hitting enter, and to terminate the execution of program, this hit enter at the beginning of the file only. So this will create a string of 0 length, as we have seen strlen we have used, which the program will recognize as exiting, means signaling the closing of the file. So we have to set a character array, as we have seen, to receive the string. The fputs function writes the content of the array to the disk now, and this fputs does not automatically add a new line character. /n is not automatically added. That is why we have explicitly added, just to make it easier to read the string back from the file. This we have by ourselves added. Now we have a program that reads strings from disk file. We have already written it. Assume that we have written it, and this reads strings from the file, and we want to display that on the screen from a file. So we have stdio.h, we have file pointer. This is the buffer or character array. This is the file we have opened for read, and we wanted to open it. If it is not opened, we say okay, there is a problem, we come out. Otherwise, if things goes fine, we'll use fgetS. Because this is 80, we go up to 79. This is exactly equal to that number only, and this is fb. So when we are using fgetS, we are trying to find out when we reach the null. If one by one we are reading it, one by one strings are being read, and they are being printed till the time we reach the end, that is the null, and we close the fp. So this is the sample run of the program. So this fgetS takes 3 arguments. Please understand, it takes 3 arguments. The first is the address of the string which is stored. The second is the maximum length, and this argument prevent the fgets to read or overflow the array. The third argument is the file pointer, and when all the lines from the file have been read, we attempt to read one more line in which we get null and we come out. I'll show you one more time. This fgetS use three parameters. S is the character, this buffer we have used. This is the size, which is this size, and fp is the file pointer. And there is something when we are dealing with the file and we are reading and writing, so we have written a program that counts, or just assume that we wrote a program that count the total number of characters present in that file. So if you use the program to count the number of characters present in the, say, some poem.txt, this is imaginary file, and if we count it to be 101, but if you go to the directory and we see that it shows 105 characters. Why are these 4 characters deficit, or why is this 4 more? There is a discrepancy. That is what is the awkward new line. This discrepancy occurs when we attempt to write /n to the file using the fputs. What this fputs does, it takes /n and it put /r/n instead of /n. So this is a combination. This /r is nothing but the carriage return, and /n is the line feed. So if we read back now, we have done it using fputs. When we use it, we use fgetS, the reverse conversion happen. So when we write the first line of the, say, some file and a /n using 2 calls of fputs, we get this, right? /r/n is in the place of /n. So when the same line is now read, it is being read back into the array, say this buffer as a character array. If you use fgetS, the array will contain like this, not /r/n but /n/0, and the conversion of /n to /r/n and then again /r/n to /r. This is the feature of standard library function, and this is not the feature of operating system. So operating system will count /r and /n as separate characters, as 2 characters. So if we have, say, some 4 lines, you will always find in that we assume that our file has 4 lines. So we have 4 /n to /r/n conversion. So as we have 4 character more, it will count, the operating system is going to count 4 more. That is why the discrepancy is there. Record input output in file. We can read one by one character, we can read one by one string from the file and write to some other file. Now if we want not only the characters but strings and number, because we are dealing now with, or we want to deal with the dissimilar data together in a structure. So for that we use this fprintf and fscanf library function in order to read, write data from or to file. So we will write a program and we use these structures for writing record of employees. We have this program, right, which records or write records to the file using structure. We have stdio.h, so we have a file pointer. We are trying to say user that okay, you say yes till the time you want to enter the data, otherwise you say any other thing apart from y, you come out. So we have declared a structure which is emp. We have a name, age and basic salary. We have a variable, structure variable. Now we have opened a file now, and this is in the write mode. If it doesn't open, we say okay, we come out. Now if everything goes fine, we say while another equal to y means we will take the character from the user, and till the time he says yes, we will do or we will run this loop again and again till the time he comes up with a character other than y. So here we say this printf enter name, age, basic salary, and we scanf it in ename &e.name and &e.bs. Why we have not used ampersand here? Because this is a character array by itself. Now we use fprintf. Now we use this fprintf to print or to put the values which we have got here from scanf to the fp, that is the file pointer. So in this file we want to write ename, age and e.bs, and after that we will ask user if you want to enter more. He says yes, we'll go on and on, otherwise we come out. Then we close the file. So this is the sample run. User has input 3 times. So in this program we are just reading this data into the structure variable using scanf. Now we want to dump that into the disk, and we use fprintf exactly for that. So the user can input as many as record till the time he doesn't come up with any other character other than y. So the key of this program is fprintf, which is writing the value or in the structure variable to the file. So this is similar to printf, except this file pointer is included as the first argument. As we have seen, is in fprintf first argument is the fp. So as in printf we cannot we can format the data in a variety of ways. As in printf we can have a format specifier, we can have format specifier in fprintf also, fprintf, and we have used something called fflush. Fflush is what? Fflush stdin generally we use. Nowadays we don't use it, but you should know about fflush. What happens here? This is just in order to avoid one peculiarity of scanf. Whenever we are using keyboard and whenever we are applying the content to the scanf, it assigns the name, age, salary to appropriate variable, and it keeps the enter key unread in the keyboard buffer. This is the thing. It will keep the enter key unread in the keyboard buffer. So when it's time to supply y or no, the question, if it arises in our program, this getch will read the enter key from the buffer, thinking that the user has actually pressed the enter key. And in order to avoid this situation, we use the fflush. So this is like the flush we use. It is designed to remove or flush out anything which is remaining in the buffer. So the argument in fflush we have used stdin. Stdin stands for standard input, which is actually the keyboard. So now let us write the program to read the employee records created by the program we have just written. Now we took the input from the user, we have placed it in the file. Now we want to read from the file. So this is the reading record from a file using a structure. So again we have stdio.h, we have a file pointer, we have a structure here. This is a structure variable, and this file we assume the content is already written, and we have 3 content written here. The name, age, bs, like this. So we want to open this file in read mode. If it is not open, we raise an error. Otherwise we just do one thing. Fscanf, we are scanning from the file fp. What we are scanning? The name, the age and the bs, basic salary, and till the time we reach end of file, we just read it and just print it. Simply printf we use, and we close it. So this is the sample run. So this is the first discussion on the file input output. Text file, also with binary file. A text file contains the textual information like the alphabets, the digits and the special symbol, but actually all these are the ASCII codes. For example, if we have say some file like this, then when you open it in some text editor, you will find the text, but the binary file is just collection of bytes. It may be a collection of say compilation, or it can be an object file or an exe file. It can be say a wave file or a media file. Now there is a difference between this text and binary. When we are actually dealing with file input output, we are able to see the text file but not binary file if you want to open it in some text editor. So there are certain differences. As I can show you one program. We had already done this file copy program. We have taken one file, another file, we have used the character copying, means the first file we took the character and transferred the character in the target file, and one by one we did it till we reached the end of file here. Now if we want to deal this in binary way, how to deal this way? We have stdio.h, we have file 2 pointers, this is source, this is target. Now we are opening this is an exe file. Please understand, this is an exe file. So we are opening it in RB, read binary. If it is not open, we say okay, we come out. Otherwise we open the target one, and this is also the exe file, but it is a write binary file. Again, we check for its existence and or if any other problem is there. Now with an infinite loop, we take one by one and then we say, okay, if end of file is reached, we come out. Otherwise, we take all the character which are coming from the FS source and we transfer it to the target. If we use this kind of program, we can easily copy the text as well as the binary file, because we are using RB and WB, right? RB and WB, these are the mode in which we open the file and for reading and writing. While we are using the text mode, we can use R or RT. Actually, we use only R. We never use RT because this T we drop. This is RT is for text mode, RB is for binary mode. So this program, or with the perspective of programming, there are three main areas where this text and binary mode file, they are different. First, when we are dealing with the new lines, what is the end of file and how the numbers are stored. Let us see all these differences. First of all, the new lines, text versus the binary mode. In the text mode, the new line character is converted into /r/n. That is a line. This is a carriage return and line feed combination. So the carriage return and line feed, this is converted back when we read it. When we write it, this way it happen. When we read it, this way it happen in, say, some C program. But if we open a file in binary mode, this conversion will not take place. End of file, text versus binary mode. The second difference between the text and binary mode is the end of file. In the text mode, we have a special character whose ASCII value is 26, which is actually inserted automatically as the last character in the file to mark the end of the file. If this character is somewhere, the read function would return the end of file signal to the program. But in binary mode, we have no end of file. End of file marker is not there. In the binary mode file or the binary mode, the files keep track of the end of the file from the number of character which is present in the directory entry of the file. This is the important difference. So what is the moral here? What is the crux? If the file stores number in binary mode, it is very important that the binary mode only be used for reading the numbers back. This becomes very important. Why? Because say you one of the numbers you store might well be some 26, which is the hexadecimal equivalent of 1A. So if this number is detected while you are actually reading the file by opening in the text mode, the reading will be terminated here prematurely. So this you have to consider. These two modes, they are not compatible. That is, if you have written in text mode, always read back in text mode. If you have written in binary mode, read it back in binary mode. Then it comes to the third difference, storage of numbers when we deal with text versus binary. The only function which is with us for storing numbers in a disk file is fprintf. Now, how we store the numerical data in disk by fprintf? The text and characters, they are stored one character per byte, as we are going to expect. So are these numbers also stored as they are in memory? Say 2 bytes for integer, 4 bytes for float, and like that? The answer is no. It is not stored like this. The numbers are stored as just string of characters. If this is a number 1, 2, 3, 4, even this occupies 2 bytes in the memory. When it is transferred to the disk using fprintf, it would occupy 4 bytes. How? This is 1 byte, 2 byte, 3 byte, 4 byte. That is 1 byte per character. Similarly, if you have this number 1, 2, 3, 4, 5, 6, 7, the floating point number, this one would occupy 7 bytes on the disk. So the number of more digits will require more disk space. So if we have a large amount of numerical data which is to be stored in the disk file, if you use text mode, it will be inefficient. What is the solution? The solution is in the binary mode we use the functions called fread and fwrite. We'll talk about that, which actually stores the number not in text format but in binary format, which means each number would occupy same number of bytes. That is, if they are integer, all will have 2 bytes depending upon the compiler. Float 4 bytes likewise. Record input output. The record input output program, we have already done that. That is, we have a structure. In that structure, we have made a variable, and depending upon that variable, we put or place the value from the keyboard in that file. We opened a file also, and then after that we read the record which we have entered using the reading of that file. So the number which we have used, say for example basic salary, it would occupy more number of bytes. Since the file has been opened in text mode, it will be simply one character by one character. So how many numbers are there, that many bytes are used. So this is because when the file is opened in text mode, each number is stored as a character string, like 1, 2, 3, 4. So that means 4 bytes will be taken, but this is an integer. Essentially it should take 2 bytes. So if the number of fields in the structure as we have defined a structure, if you want to add more thing like address, HRA, etc. So writing structure using fprintf and reading fscanf will be quite clumsy. We will have an efficient way of reading and writing records, that is the structure. Two functions are fread and fwrite. So we will write two programs. In the first, we will write the records to the file, and in the second program, we will read this record from the file and we'll try to display it on the screen. So this is the program to receive record from the keyboard, and we'll try to write them to a file in a binary mode. This is the mode we are going to use. So we have a file pointer. We'll say user. Till the time you press yes, we will allow you to enter the content. This is a structure, name, age, BS, and we have a structure variable. We have opened the data file, that's a dat file, in WB, write binary. If it is not open, we say cannot open the file. Now we ask the user to enter name, age, basic salary. We use the scanf, and now we use the fwrite. This is the crux of this program. We are going to discuss essentially this. Fwrite, what we are using here is we are using the address of E, that is the structure, the size of E, that is the size of the structure, and at one time we want one record, and this is the file pointer, and we say we want to add another, so we will allow user to enter the content as many times he wants till the time he presses yes, and we come out FP. This is a sample run of this program. Now this program is quite similar to what we have done earlier, where we have used fprintf instead of fwrite, but here we have used the data file emp.dat, and we have opened it in the binary mode. So the information which is keyed in through keyboard about the employee is placed where? In the structure variable E. So this is the statement. This is the statement which is writing the structure to the file. This is fwrite, and what all are here, I'll explain you one by one. This first argument is the address of the structure to be written on this disk. The second, as you just saw, is the size of. So the second argument is the size of the structure in bytes. Rather than counting the bytes occupied by the structure ourselves, why not we let the program to do the stuff? So that is why we are using the size of operator. The size of operator gives the size of the variable in bytes. You can use float, you can use like other data types also. So this keeps the program unchanged even if you want to add more elements to your structure. Then we have the third document, as you just the argument as 1. So this is the number of such structures that we would write at a time. So we want to write only one, so we gave 1. We want to had more, we have to have more structure. Say we had an array of structure, we want more than one to be written or read. And the last argument is of course the pointer to the file, that is FP. Now let us write the program what we have written in the emp.dat. Now we would like to take it back, means show it onto the screen. So we have this program which reads record from the binary file, and it will display them on video. So this is stdio.h. We have main file pointer, we have a structure like that, and now we have a structure variable. We have now opened this file in read binary mode. If there is a problem, we indicate it. Otherwise we just fread till this is equal to 1. That means the %e, size of the E, that is the structure, 1 record at a time, and file pointer. And now we can show the content e.name, e.age, e.bs. This will work fine. So this fread function, it causes the data to be read from the disk and to be placed in the structure variable. This fread is quite similar to fwrite. This function fread returns the number of records which has to be read. This should correspond to the third argument, the number of records that we just said 1. So if we have reached the end of the file, this fread cannot read anything, so it returns 0. So we can just test this situation and we stop the reading. If you want to make very small database as a beginner, we can use this fread and fwrite function, because they are able to store the number quite efficiently and make the writing and reading of the structure quite comfortable and convenient for us. Even if the number of elements belonging to the structure would increase, fread and fwrite will not have any effect. Now database management, with if we are dealing with files in C programming, the input output can be done in bits and pieces. But if you want to make a simple menu driven program, you want to have a provision of adding, modifying, listing and deleting the record, the content can be said, or the program can be said as the replica of a small database management system. If you want to add the record, it must always take place at the end of the existing record in the file. Then listing the record, all the records should be displayed. Record should be listed from first to last. While we are trying to modify the record, that is, we want to change one record. One thing is to, if you want to change this record, so one way is to take all the record which are apart from this and copy overwritten to the new record, or we can leave it, or we can write anything on this record. When we want to delete, again a temporary file is created. You can create a temporary file and just delete that part and copy all other stuff to the next file. And just see the way we have opened the file. For reading and writing, if it fails, then we have to say that it has been failed. We need to know that the file should be opened in binary mode here. And since the file is being opened only once, we have to close it only once, which is quite logical. We have some CLR, SCR, gotoxy means go to XY position. All these are being discussed already. So here is a complete listing of that program, simple database management program. We have two file pointers, FP and FT. This is two file pointers. We have some variables. We have a structure here. Now this is a structure variable E. We have a character array which is employee name, and we have REC size, right? Record size. We have opened the file in RB plus, read binary mode, and write binary mode. The first one is emp.dat. The other is also emp.dat. But this is inside it. If it is read binary, if FP is at all null, we will try to open it in write binary. Means if it is not opening, then we will create a file. And if at this point also it is not open, we indicate an error. Now this record size can be easily computed by the size of this E, size of E. So this infinite loop we have taken, and we add record. These are only the row and column positions, so don't worry about this. Adding record, listing record, modifying record, and delete record. We have exit also. We'll take the user choice, and depending upon the choice, we'll go to different choices. For example, this is one. This is adding the record. So if you want to add the record, you have to go to the end. This is seek end. FP you start, use 0, and this is seek end. And we ask the user how many times you want to enter, and this just we printf that please enter. We scanf, and we just fwrite this %e with the record size in FP, and we ask the user to put no so that he can come out. The second one is the rewind FP. That means what? Second is the listing of the record. So we have to start from the first record. So we have used the function called rewind. We have reached to the first, and now we are reading each record and just displaying it. This is a listing of the record. Now you want to modify the record. We have case 3. You just have to enter the employee to modify. Scanf in this employee name. Rewind it to the FP when start from the first, and just try going to that, comparing that EMP name which has been entered with the E name with all the records. If you found one, then you have to change it accordingly. Now this fseek is just taking you to the previous record, seek cursor. If this is a cursor minus REC means if this is the record, it will take you to this record, the previous one, and now you write it. And the last one is the deleting. So if you want to delete, you have to ask for which one you want to delete. You have to go to the first, means you have to start from the first, and each record you have to take, you have to compare the employee name with that record you want to delete, and you just delete it. And this is FP and this is FT. So what you are doing is, you are taking one record, copying it to the other one, and you are just skipping that record which is matching here. So this is how it is done. Then you have to remove this original file, and you have to rename this file as the previous file. This is how it is done. And this is a program which we have many functions which we have used for the first time. Fread, fwrite we have already seen, fopen. This all starts with the beginning of the file. So this rewind function takes you, or this function places the pointer to the beginning of the file, to the initial, wherever it is. Then fseek, this allows you to move it in the file, here. So it lets you move the pointer from one record to another. In this program, to move the pointer to the previous record, we use this one. We have moved to the one previous to the current position. This minus REC size moves the pointer back to this number of bytes from the current position. And this seek cursor is a macro actually. It is defined in stdi.h. Similarly, we have fseek. This will place the pointer beyond the last record in the file because we have used seek end with 0. This minus REC size and 0, these are just the offset, that how much you have to move the pointer. The third argument here, seek end, seek cursor, seek set. As we said, these are all the simple macros, and these act as the reference from where the pointer should be offsetted. For example, seek end means move the pointer from the end of the file, end. Cursor SUR means move the pointer with the reference to its current position, and seek set means move the pointer with the reference to the beginning of the file. This set means beginning of the file. We have also ftell, that means we want to know where the pointer is right now, where it is positioned right now. For that we can use ftell. And this ftell returns long int, which is actually the offset from the beginning of the file. So the value which is returned by ftell can be used with the fseek. For example, this ftell, fp, it will tell you the pointer which is position right now, and this position can be used because it is returned as a long integer. Now coming to low level disk IO, in the low level disk IO or input, this data cannot be written as individual character or as a string or as a formatted data. There is only one way this can be written or read in low level disk input out function, just as a buffer of full of byte. So buffer is being written, and when we are writing buffer full of data, it just resembles the fwrite function, but unlike this fwrite, the programmer must set up the buffer for that data and also place the appropriate values in it before writing and taking them out for writing, right? So the buffer in the low level input output function is a part of the program, rather than if we use high level disk IO functions where it is virtually invisible. And this low level disk input output functions, they offer various advantages. What are these advantages? Since these functions parallel the methods of the operating system which is used to write to the disk, they are quite efficient than the high level disk input output functions. And since we are dealing with fewer layers or less layers of routines to go through, this low level input output function, they operate faster than their high level counterparts. And let us write a program for that now. This is a low level file copy program. We had already seen a program to copy the content of one file from the another to the another. We have used this fgetC. We took one character, then we fputC, that is put one character. So instead of this performing the input output character by character, let us take the chunk of bytes from the source file and transfer it to the target file. So whenever we are doing so, this chunk, this buffer will be written. So we will have to manage the buffer ourselves. We will not rely on the library function. So this is what the low level program or low level dealing is. So let us see the program now. This is a file copy program which copies text.com.txt file. We have, apart from the traditional file we included fcntl.h, types.h, stat.h. This types.h, this is present in this directory, stat is present in this directory. So we have made this program as a command line program. We have different buffer and source and target. We have various integer variables also. You'll see what these are going to do. First of all, we'll ask the user to enter the file name. Will get us the source and we'll try to open it. This is the function we use. See, this is the low level counterpart. So this is the source and this is read only and binary in handle. Then we have, if this in handle is 1, we say we are not able to open. Then we go to the target file, the file name. We enter it, we try to open it again. But these are different scenarios. We are going to discuss this just now. If this is again -1, we say we are not able to open. If these two are not, means everything is fine. We just read the 512 in the buffer from the in handle. If bytes is greater than 0, we just write this to the out handle. We take this buffer, number of bytes, because these bytes with the buffer is being written to the out handle. Otherwise we break. And we close the in handle and out handle. So this is a program, low level file copy program. How to declare the buffer? The first difference here is we have a character buffer, which is character buffer 512. So this is the buffer in which the data read from the disk will be placed. And the size of the buffer is important because we want an efficient operation. Depending upon the OS you are on, buffers of certain sizes, they are handled more efficiently than others. When you want to open a file, we have opened two files. One is the source file, one is the target file. So we need certain information how to open this. At the high level disk IO, the file must be opened before we can access it. This is done using open, source, O, RD only and O binary. So when we open the file, for the same reason, this is establishing a communication with the OS about the file, and we have to supply to open what? The file name first of all, and then the modes in which we want to open the file. So these are the possible modes, opening mode in the low level operations. O append, this is opening a file for appending. This is creating a new file for writing, creating a new file for reading only, creating a file for both reading and writing, RD, WR. This is creating a file for writing only. This is creating a file in binary mode, and this is creating a file in text mode. This O flags, these are in fcntl.h. So this file must be included. Otherwise, other things are available here. stdo.h. This O flags they can be separated by pipe. This is just an OR operator. For example, this statement we have used in our program. Here you see O create flag, and we wanted this target file. If it is not existing, we want it to open O create flag. Then we want to write to the file and not read from it. That is why we have used the OWR only. And finally, we want to open the file in binary mode. So for that we have used this O binary. This O create flag, once this also you saw, This is also one of the argument, and this has added to open just in order to indicate the read-write status of the file to be created. And the argument is called the permission argument. This argument is this permission can be as I write, as I read. This is writing to the file permitted, and this is reading from the file is permitted. And for these permission, you have to include types.h and stat.h, which has to be included along with your fcntl.h. So there is an interaction between buffer and file in this program. This is the statement which reads the file and as much so that it can fit in the buffer. This read function takes 3 arguments. The first argument is the file handle, the second is the address of the buffer, and the third is the maximum number of bytes we can read or we want to read. This read function returns the number of bytes actually read. So this is important number since it may vary well by less than, say, buffer size 512. So we will need to know just how full the buffer is before we can do anything with its content. In this program, we have assigned this number to the variable which is called as byte. And in order to copy the file, we must use both read and write in the while loop. This read function returns the number of bytes, and this is actually what is being assigned to bytes. And this value will be equal to the buffer size, that is 512, until the end of the file. And when the buffer will only be partially full. The variable bytes, therefore, we will use to tell this write function how many bytes we want to write from the buffer to the target file. And now we come to input output under Windows. In input output, when we are dealing with the operating system which is specific to us, it can be Linux, it can be Windows. So in the Windows, or because we are using an operating system, then operating system we have only library functions. So we are using the inputting outputting of input output of the operating system. So we under Windows console input output functions, under Windows we don't use it. But this fprintf, fscanf, fread, fwrite, sprintf, scanf, they are also working properly in the Windows. So let us summarize what we have seen. File input output can be performed on a character by character basis, line by line basis, record by record basis, or chunk by chunk, buffer by buffer basis. There are different operations that we can perform on a file. We can create, we can open, we can read from the file, write to the file, and we can also go to or move to a specific location in a file or seek the file and then close the file. This file input output is done using buffer in order just to improve the efficiency. A file can be text and binary depending upon the contents. The library functions convert /n to /r/n and vice versa while we are reading and writing to and from file. There are various library functions which can convert a number to a numeric string before writing it to a file, and it may use more disk space. You can avoid it using fread and fwrite. In the low level disk IO, we can do the buffer management ourselves. We have to do it. So this is all about this chapter. Thank you so much and take care of yourself.